So do guys. All right. All right, so let's look at day 2 of 4-4. So we're going to go from where we left off. So now we're going to find the values using a calculator. What do we have to be careful of?
Radians and degrees.
Very good. So we have to be careful. Are we in radians or degrees? So where do you figure that out? So here's mode, right? So look at your mode. What am I putting into my calculator?
Degrees.
So what do I want my calculator in?
Degrees.
Yep. And currently my calculator is lit up at degrees, so I'm good. If it's not lit up, then you need to make sure it's lit up. And press enter. All right, so find sine of 40 degrees. Real simple, right? Type that in. And for these ones, I want you to go out to 4 decimal places. So it's approximately, because we're rounding, 642, because there's an 8 next door to the 7?
6428.
6428. Then cotangent. How are we going to find cotangent? Yeah, so we're putting 1 over the tangent of 410. This will be interesting. We're actually, well, yeah. What quadrant is this going to end up in? Because all the way around is 360. And then what's 410 minus 360? 50 degrees. Won't you end up in the first quadrant? So we are going to do 1 over the tangent of 410, right? Degrees. So 1 divided by tangent of 410. What'd you get? 8391. I want you to try something. What would also be 8391? Try it. 1 over 1 divided by the tangent. Huh. Why? They're coterminal, aren't they? They're coterminal. And wouldn't 50 degrees be my reference angle? So we've been using a lot of reference angles without the calculator, right? So a reference angle can get you the same degree measure also. So we really only need to go up through what? Remember your table of values in the back of your geometry book? Had sine, cosine, and tangent. It went from 0 to how many degrees? It did not go to 360. 1 to 90. Would that work for everything? What if you have an angle in the second quadrant? Wouldn't you use a reference angle here? Which would be, again, less than 90 degrees. Wouldn't all your reference angles be less than 90 degrees? Yeah. Question.
I'm just wondering, like, what's really the math behind
Tangent is sine
like,
over
what's the
cosine.
math behind all of it? Is it really
It's all based upon right triangles.
There's no, like, formula?
What do you mean by a formula?
It's like, is there a way to break it down?
Is there a way
Plugging that into this calculator.
Yeah, what is a calculator doing?
Do you really want to know that? It is calculating the ratio of the side of, okay, so if your reference angle here, if your reference angle here is 50 degrees, it doesn't matter how big or how small your triangle is, right? But you can still have a 50 degrees there. Won't your side, for tangent, won't your side opposite over your side adjacent always be the same ratio if you have a 50 degree angle? And that ratio is 0.8391. Well, in this case, it's cotangent, so it's 0.391. Every cotangent of any 50 degree angle, no matter what lengths of sides that I give you, as long as it's a true 50 degree angle, it will always give you that ratio. So that's the ratio of, in this case, because it's cotangent, isn't it cosine over sine? Or not opposite over adjacent, but adjacent over opposite, right? So that's what it's telling you.
But how does it?
And that's how your calculator is calculating it. Because it knows that no matter, they went and they took, a triangle, let's say, and they had, I don't know, one leg was 10 units. And they kept changing the degree of one of the acute angles in the triangle, and they kept changing the degree and lengthening the hypotenuse in the other leg. And they kept figuring out what are the ratios for a 1 degree angle, a 2 degree angle, a 3 degree angle, a 4 degree angle. And they found that, because I can make a reference angle that's always between 0 and 90, they found out there's always the same ratios. No matter how big or how small the sides were, as long as the degree remained the same. Because there's only one way you can make a triangle. It has to pass Pythagoras' theorem, right? So that's how they discovered what the other leg and the hypotenuse would be. Okay? All right, so are you satisfied with that? When we get to some other points, I'll show you. We can look at different triangles with different side lengths that have the same angle, but that's really what they've done. All right, so this time this is in what? Radians. So we are using our calculator. So I'm going to clear this out. We're going to change our mode to radians. So you might want to write in your notes here, change mode to radians. So I'm going to go into my mode, and I'm going to scroll down, hit enter, so that it's now flashing and highlighted. And then I'm going to do just tangent. Please use the pi on the calculator, not 3.14. So 14, second function, your caret, gives you your pi, then divided by 5. Please finish out and close your parentheses. Now hit enter. This is giving us the same ratio as if it would be in degrees, by the way. Because it's still, this is the ratio of side opposite over side adjacent. For whatever degree this is, we'd have to translate it, wouldn't we? Okay, well, we're not going to. So go out to 4 decimal places, so negative 0.7265, right? Round correctly. There you go. So now we can put our calcs away.
We need it on the back.
Do we need it on the back? Oh, yeah, well. Oh, see, there we go. I just didn't want to use the calculator. I love doing it without. All right, so now we have to find 2 solutions of the equation. So you're like, 2 solutions. Because look what they're giving you. They're not giving you theta. Aren't they giving you, okay, sine, isn't that side opposite over hypotenuse? Aren't they giving you the ratio? But not in its decimal form, in its actual, this is the actual ratio. If I were to take the square root of 3, so I'm going to turn, they want our answer in both degrees and radians, so I'm going to start with degrees. So I'm going to go back to my mode and change it to degrees. I'm a little partial to degrees. Well, you could. Well, yes, you could. No, for example 5? Oh, see, you guys are such liars.
No, example 6 is
Number 3.
You're killing me today. All right, I'll just wake up a little bit. All right, so what do I start with here? What should I start with here? Not just a triangle. I have to use a coordinate grid, and it's important. So let's start off with a coordinate grid, and I'll tell you why. We're silly today. Really silly.
Yes, we are.
And it says give 2 solutions. The sign here is positive or negative? Okay, so sign is positive, right? Which of these 4 quadrants is sign positive in? Positive here and all students, and also here. So immediately I'm going to make what kind of looks like a bow tie. So I'm going to go up, down, right angle, right angle. Here is the theta that I don't know what it is. Now some of you have been memorizing the ordered pairs, right? Okay. And so if that's the case, you should already know the answer. Is that what you're touting over there? Yeah. Okay. And then she already knows the answer, but here's the problem. There are actually 2 answers, so you do have to think about, okay, it's the ordered pair in this quadrant and this quadrant. So you do have to consider full, where would sign be positive? Because there are 2 y values, remember sign is y, on those ordered pairs where it's positive 3, radical 3 over 2. Am I correct? But that would be with reflections, right? If you reflect the first quadrant over here, won't it go over here? Won't y reflect positively? That's what I'm talking about. You're looking at me with a blank face. Did you memorize all 4 quadrants or just the first? Okay, so she's not even reflecting. Do you have a photographic memory?
But it's the same every time, just follow the rules of the coordinate, and click on that, and I'll positive that one.
So she's naturally reflecting it. Okay, just watch, just looking. All right, so here, if this is my theta and this is opposite over hypotenuse, they're all looking at daggers at you. How can she know that already? Opposite is radical 3, radical 3. Try it again. My pen doesn't want to go with my mouth. Yes. Is she being funny? And then my hypotenuse is 2, right? And then over here, my side opposite is positive radical 3, and my hypotenuse is 2. Well, that means that what number's missing here? 1. And then this would be a negative 1, right? But it's still, we can look at it as 1. Triangle is this? So 30, 60, 90. Theta is across from rad 3, so what is theta? 60 degrees. Now, from here to here is 60 degrees, right? But from here to here is what? What's 180 minus 60? This is 120. So your 2 answers are this. Theta, let me get my pen here. So theta is equal to 60 degrees, and then theta is equal to 180 minus the 60 degrees, which is 120. Okay, so now we're going to change that to radians. What's the radian measure? Because we can do this without, shouldn't we be able to do this without thinking? This is pi over 3, right? And then this is twice this, isn't it? Isn't this 2 pi over 3? Or you can use your conversion of what over what? Pi over 180. So you could multiply this by pi over 180 and this by pi over 180. Absolutely perfectly fine. Whoops, you didn't tell me you couldn't see it. Okay, so try B on your own. See if you can do that on your own. Going through the same kind of steps that we just went through. I'll quietly do it up here. And as you go along, you can check. What did you get for theta? It is across from 1. Did you recognize again it was a 30, 60, 90 triangle? And my parts of my bow tie are in the second and third quadrant. Do you see why? If my positive quadrants are all are positive here, students take calculus. That means that cosine is positive here and here and here. So I did my right triangles here. Here's my theta. Here's my adjacent over hypotenuse because it's cosine. So to this theta, this is adjacent, that's your hypotenuse. To this theta, this is still adjacent, that's hypotenuse. Because this is your x-axis, this adjacent radical 3 is negative. Hypotenuse is always positive. What's missing from the triangle? 1. This is a positive one, this is a negative one because this is the y we're positive and this is where the y is negative. Are you all okay with everything I did so far? So theta is across from 1. What does that mean theta is? No, just what's theta my reference angle right now? Okay, so right now, this theta is 30 degrees. But that's not the answer, is it? Because from here to here is what I want. So what's 180? One of my answers is, for theta, is 180 minus the reference angle of 30 degrees, which is what? There's your 150. And then my other theta is 180, but plus the 30 degrees, because I want to go this far down to here. So 180 plus the 30 is 210 degrees. And you want to make sure that those angles appear in quadrant 2 and quadrant 3. Wouldn't these be in quadrant 2 and quadrant 3? If you just said 30, 30's in quadrant 1, that can't be right. Now, radian degrees. 30 degrees is pi over what? 6. If this is 1/6, and this right here is pi, isn't this 6 pi? This is just 1/6. What's 6 minus 1/6? So that's one way that you could do it, 5/6 pi. Or again, you can convert it by doing pi over 180, right, and reduce. And then here, won't I be taking 6 and adding 1/6 pi? So doesn't this become 7 pi over 6? Or again, you can convert by multiplying pi over 180. How'd you do? Does that make sense though? Questions on that? Places where you're fuzzy? You just need to let it sink in for a little bit? Or are we tired? Or tired? You can't be tired. All right, example 6, what are we going to use? Oh, well, there we go, a calculator. All right, so use a calculator to approximate two values. So again, we have to pay attention to two values of theta that satisfy the equation. So we have to pay attention. I'm still going to encourage you to write your coordinate grid. Okay? This time cosine is what? Cosine, and this is your ratio of adjacent to hypotenuse. Since we asked, that's what that is. It's positive, isn't it? Where is cosine positive if I've got all students take calculus? It's positive here and here, right? So that means that my theta is here and here. So one theta is going to be less than 90. The other theta is going to be somewhere around 300 something, right? To get into the fourth quadrant. Am I right? Okay. So let's see what the calculator says. I want, did it say whether I had to have it in degrees or radians? If they don't ask, I would just put in degrees. If they don't ask, I like degrees because that makes better sense to us. If I gave you an answer in radians, does that make a whole lot of sense to you decimal-wise? No, the degrees make more sense. So make sure that your calculator is in degrees. Mine is. And then how do you do this? How does this get plugged into the calculator? The inverse. Remember, if you don't know theta and they've given you this, you're going to put into your calculator cosine, the inverse cosine of, and then you're going to put the decimal equivalency in there that they gave you. That's going to be what theta equals. So you want to hit second function, cosine, and then put 0.8746 in. That's closest to what degree? I'm going to go with 29 degrees. So that means that theta is equal to 29 degrees. Because one of my answers in the first quadrant, I'm going to take that exactly as it is, right? That means that this theta here is 29 degrees also, but is that what I'm looking for? I want what goes from here all the way to here. So for the second answer, I'm going to take 360 and subtract the 29. What do I get? 331. No. Even though technically you're correct, let's not. But I see why you might look at it that way. All right, so.
I'm sorry, for the first, you need to see us draw that out.
No, it's just really helpful for you. So you can see what to do here. and what would make sense. Because if I get two different answers, I'm gonna go, okay, yeah, that's in the first quadrant, and yeah, that belongs in the fourth quadrant. So you do B on your own. Again, I'll quietly do it over here. But remember, this time sign's negative.
Should we round to the nearest degree or?
If it doesn't say, I'd round to the nearest tenth. Yeah, I'm gonna stop there till you all get caught up, and we're gonna talk about how to deal with this.
We just added, like, subtracting everything.
Well, our reference angle is about 28, 29 degrees, right? What am I gonna do to 180 with this 28.64? Well, technically I'm subtracting it, right? Technically I'm doing 180 minus the negative 28.64 because I want to add it to that, right? I want to make, this angle needs to be bigger than 180 degrees to land in the third quadrant, doesn't it? So I end up with 208.64, right? Will that be in the third quadrant? Does everybody understand how I got the third and fourth quadrant? This is where sine is positive. Well, this is where sine is positive. That means that this is where sine is negative. All right, so then to get the second theta, I want to get in the fourth quadrant. So what do I do? Fourth quadrant is 360, right? So I would add, I guess, the negative 28.64 because I really want to reduce the 360, right? Or you could just subtract a positive 28.64, right? And what do you get? And will that end up in the fourth quadrant? Yes. So we somewhat kind of ignored the sign a little bit, didn't we? And manipulated it to serve our purposes. And that's why it's really handy to show this. So you kind of know what you're doing with 180 and 360, right? I know I need to get less, I know I need to get more, so that tells you kind of where to go from there. All right, any other question? All right.